Hello students, hi, I'm Saurabh Singh and I've done my BTech from IIT Patna. Today I'll be talking about the chapter sequence in series. As far as JEE Main and JEE Advanced is concerned, it is one of the most important topics that we should put our focus on. So let's start with the topic. So what does the term sequence in series mean? The term sequence, it means that it is a succession of numbers that is formed according to some definite rule. Or you can say that, suppose for an example, we take 49 root 397 minus 80. Another definition in terms of mathematics is that it is a function whose domain is a set of natural numbers and range depends upon the type of sequence we consider. If we are considering a real sequence, the range is going to be real. If we are considering a complex sequence, the range is going to be complex. Now the other term which we will see frequently in this chapter is progression. So what is progression? Progression is a sequence having terms in definite pattern. So we see that there is a pattern in progression and there is a pattern or rule in sequence. So what is the basic difference between progression and sequence? In sequence, there is some definite rule. It is mathematically possible or it can be defined in terms of explicit values. But this progression, in this, the pattern is definite. For example, suppose I have a pattern that each term of the progression will be n upon n plus 1, where n will be natural number. So what I can say that the first term of this progression is going to be 1 by 2, the second term of this progression is going to be 2 by 3, third term 3 by 4, and so on it will go on. And the third term which will be used more frequently in this chapter is series. So what is a series? When the definition says it is formed by adding or subtracting terms of a progression. Or in other terms we can say that when we have a progression and we do certain kind of arithmetic operations on those progressions, we get a series. As far as the course content of this chapter is concerned in terms of JEE, we have three different kinds of progression which we will read in this chapter. The first one is AP, that is called as arithmetic progression. The second one is GB, that is geometric progression. The third one is HP, that is harmonic progression. First of all, we will go with the details of arithmetic progression and then we will see what are the rest of those. How we define arithmetic progression? Arithmetic progression is defined as it is a progression in which difference of consecutive terms is constant, that is D, which is also called as common difference. What we can say here is that term 2 minus term 1 will be equal to D, term 3 minus term 2 will be equal to D, term 4 minus term 3 will be equal to D. Or in other cases, if you go in backward direction, term 1 minus term 2 will be equal to term 2 minus term 3, term 3 minus term 4. Now we will come to the general term. T denotes term number and n denotes what is the index of the term. So this is equal to A plus n minus 1 times D. A is the first term of the AP, n is the index for which we are writing the term, and D is the common difference. This is the general form of the term of an AP. Now we will come to the sum. This formula denotes the sum of first n terms of an progression taken in increasing order from 1 to n. So what is this? This is n by 2 times twice of first term plus n minus 1 times d. In this case, n is the number of terms which we are considering, a is again the first term, n is the total number of terms which we are considering for calculating the sum, d is the common difference, which is also equal to n by 2 times a plus l. A is the first term, l is the last term. We are using this relation for the value of sum because we know that the terms are sum of the terms. If we take in an AP, starting from the first and from the last, the terms which are equidistant, they'll have some constants. What do I mean to say here is that if we take term number 1 and term number last, that sum will be equal to term number 2 and the term number second last. So, suppose in a given question, if we have to take the number of terms in an AP, and what if the number of terms that has to be taken is odd, so we have to take in our mind that the common difference which we are going to consider for this term has to be D. So you can see that term 2 minus term 1 will be D, term 3 minus term 2 will be D. But if we have to take it for even number of terms, what do we see? We see that we have to take any series where the common difference is 2D. As you can see, a minus D minus a minus 3D is going to give me 2D. A plus D minus a minus D is going to give me 2D. Why do we do all this kind of different approach? See, whenever you are given odd terms or you have been given even terms, if you add all those terms, you will get only A. Suppose in a given question that you have been given, there are 3 terms of an AP in which the sum of 3 terms is something K. So from there, direct on I can find the value of A. If the total number of terms to be considered is odd or even. If I add all these terms, I'll only get the value in terms of A. That is why if we have to take a number of terms in AP and the term to be taken is odd, we take the common difference as D, and the term to be taken is even, we take the common difference as 2D. So now there is a problem regarding arithmetic progression. In this question, the question says if sum of the roots is equal to the reciprocal of square of root of the equation ax square plus bx plus c. As we can see, this is a quadratic equation, so this equation is going to hold two real roots. And if this is the given condition of the equation, we have to prove that BC square, CA square, AB square are in AP. Which means if we will prove that term 2 minus term 1 is equal to term 3 minus term 2, which will also be equal to twice of term 2 will be equal to sum of first term and third term. So in this present problem, what we will do, we will prove that twice of the middle term is equal to the sum of the first term and third term. So what we did in this question, we considered, suppose that the roots of this equation is alpha and beta. So according to the condition which is given in the question, we have given that alpha plus beta is equal to 1 upon alpha square plus 1 upon beta square, and from quadratic equation we know that the sum of the roots is minus of coefficient of x upon coefficient of x square, and the product of the roots is coefficient of the constant term upon coefficient of x square. So what do we do here? We take the LCM. What do we get? Alpha square plus beta square upon alpha beta whole square. Alpha square plus beta square can be written as alpha plus beta whole square minus twice of alpha beta. In this equation, what do we have? We know that we know all the values of alpha plus beta, alpha plus beta whole square, and alpha beta whole square. So what we'll do, we'll put the values required over here from this which you have defined, and I have put the value in the equation. As you can see, alpha plus beta is minus b by a, so I have put over here minus b by a. Alpha beta whole square is c by a whole square, so I have written c by a whole square. Alpha plus beta whole square is minus b by a whole square. Twice of alpha beta is twice into product of the roots, that is c upon a. So if I'll take and do some kind of arithmetic and I'll rearrange the terms, I'll get to this result, which will lead me to the fact that twice of CA square is equal to BC square plus AB square, which is the main aim of this question, that I have to prove that these three terms are in AP, which can also be shown by the fact that twice of the middle term is equal to the sum of the first term as well as sum of the last term. So here what we have did that, and hence it shows that these three terms belong to an AP.